Hello, everybody. I think most of you seen the situation when something happened and you want to know what exactly happened, but you know nothing about that. So I'll try to tell you how to solve these situations and what tools you can use, and a bit more about my experience, because I'm doing it for many years. So, some words about me, there is some facts about me, but first day when I faced the problem that I need to know what happens with my server, it was when I installed my own house network. I was its administrator, and time to time somebody called me and said, "Oh, my internet browser doesn't show me anything, or it's just something broken, please check it." And I started to ask myself why I can't do, why I don't know about that before somebody came to me. And the motivation why to do the monitoring, because you have time for things you love. You don't sit in front of your monitor and check, is it okay or not? So, the main point, it's always bad if your client or manager knows about your outages before you, because it's all about your reputation. If you can't handle outages before somebody notices it, you have a problem. So you should fight it. How? Let's try to discuss it. There are a lot of metrics that you can collect from your systems. For example, it's operation system metrics, any kind of resources like memory, CPU, network, bandwidth, and so on. In different situations, different metrics are important, so collect as much as you can. Sometimes you just can find something interesting even if nothing happened. For example, you can find some dependency between CPU graph and memory graph or network graph. So there could be a lot of interesting statistics. If you use JVM language or some kind of virtual machine language, in most cases virtual machine infrastructure gives you its own metrics. For example, how it uses heap, what kind of thread pools are allocated there, how many threads, maybe connections, and so on. You can also collect these metrics and put it into the graph. A very important thing is garbage collection pauses, because if you have too long pauses, then something bad happens with your memory and so on. Of course, you need database metrics, because if you write or read too much, you want to know when you started to read too much, or some kind of bad things happens. For example, database size grows too rapidly and you have to do something. Or maybe you see that there are too many logs happens, so you should change some queries and so on. But not only general metrics are important. Application metrics are even more important, because you can find there more detailed information and more exact information. For example, how many errors are fired during some time. For example, if you have normal error rate 10 errors per minute, and you think it's okay. In 1 day, you can see that 100 errors happened. So it means that something bad happens. Maybe some outage or some kind of security break and so on. It's very important to collect incoming requests and categorize them. For example, how many login requests, how many logout requests, how many status requests, and so on. So you understand the load profile to your system, and you, after all, you can try to repeat it and have, for example, performance tests and so on. If you use external API like Facebook, Google Service, Foursquare, it's very important to collect how much you use it, because they all have its own limits. You must be sure that you don't run out of these limits, or it could be just too expensive for you. Or there could be some delays, so you should know if once a day you have a situation when server answers after 5 seconds. It could be a problem because it affects user experience. For example, if you use some maps and on some request user see results after 5 seconds, it's bullshit and it's not a service. And another thing is user activity monitoring. It's about user actions. In most cases, it's monitored internally inside of your service. You write some code to collect these metrics and tell to monitoring server. And it could be any activity. It depends on your application, on your business, and so on. Who needs these metrics? In most cases, people think that, oh, it's system administrator need it because they are responsible for its liveness. But not only. If you're a developer and you can see these metrics, it's sometimes help you to find a problem, to face a problem, to notice it when you wasn't able before. It's much easier than digging into log files because you see the result in very convenient way for you. QA can see how good how well your product works because in some cases they can try to find the dependencies between some actions and reactions on some hardware resources and so on. They can find new problems with it. Marketing surely wants to know how exactly service is used because they can understand that this feature isn't used at all, and so why we develop it? We just can throw away and focus on things that are used and that people want. And of course, management, they want to know volumes, how many users are coming to service, how many things they buy or sell, and so on. So it's all about the money that they can earn with this service. So for them, it's also important. Here are some basic metrics types. A sample is just some snapshot of value in some time, like CPU load. Counters is just some integer or integer-like values that just increasing on some events. rates. It's about how many megabytes per second came through the wire or something, or how many times you consumed some service and so on. Aggregations, it's application of some functions on the values during some time. For example, you can calculate max values, minimum values, average values. You can calculate difference and so on and so on. And percentiles and histograms are used to distribute values and into some groups. For example, 95% use this. 95% of users use some kind of feature. It's good. Or 5% of users use this feature. It's totally unused, and so on. And of course, question rises: what can I use for monitoring to have so much statistics? Because 10 years ago it was a problem, and I'll tell you a short story about my experience. There were in late 90s we had not much tools. We had round-robin database with its tool, and we should write a lot of code to collect something to put into this database, and we used some libraries to draw these graphs by ourselves. It was totally a mess. It was MRTG that helped a lot with that, but a lot of custom code also were there. And map was big and clumsy, and it just didn't work with large volumes. So mostly we used such tools like top or stat, if top. Actually, I still use it. In 2000s, these kind of services were popular, and they were much better. They had a lot of templates. They could connect to most known services and take some metrics from there, but it wasn't enough. I still used to write some code to collect additional metrics. In late 2000s, there were two most popular services that mostly solved all the problems, but there were some problems with extensibility, especially if you need some kind of application level statistics. So, and now it's popular. Two popular solutions is Graph-IT with Grafana and a young stack called TIC-Stack. It consists of 4 components. Actually, I use it for now, and it's separated on 4 main components. It's InfluxDB. It's a database that just collects data series. Chronograph, that is just a UI to show these all graphs and helps you to configure and be a service monitoring administrator. Telegraph, it's just a data collector that have a lot of plugins for different services and with protocols and so on. I'll show it a bit later. And Capacitor, it's event processing system. In most cases, it used for notifications. So it can detect that some kind of limit was reached, and it notifies administrator or some kind of responsible guy about this event. So what I like about InfluxDB, as far as it not relational DB, it have very high performance for write, so it can write metrics very fast. It can write it with batches. It have SQL-like queries, so if you're familiar with any SQL-like database, you will easily write your queries because not much difference. No data schemas, so you just start a service and you can use it without thinking about what structures I need, what data types, and so on. It's totally forget about that. And it has out of the box some kind of downsampling, data retention. It clears garbage after itself if you need it, and a lot of different statistic aggregation functions that will. Yeah.
Is it a database specifically for monitoring purposes, or just like DEVCLUB for monitoring purposes?
Actually, it was designed for data series and for write purposes. So if you want to read much, especially with some kind of range scans, selection by key, it doesn't suit well. We did some tests and it wasn't too good. For these purposes, I would recommend some kind of database like Cassandra or HBase. But if you need just statistics, not only monitoring, but any statistics, it suits well because you can then transform the statistic in a way you want to show it.
But it's not talking about reading a lot, but about some like sophisticated reads. For example, you have like really deep nested documents being stored there, and you want to do stuff to it you normally would do to Mongo. That's very, very, very specific.
It's not document storage. It's in time series storage. In charge of this database is time. So
it's more like a DynamoDB.
I never tried DynamoDB, so I can compare. And showtime. First of all, I'll tell a bit about things I'm going to show. So I've made a demo container to demonstrate how it's all working. Here's the description of this container. So it's
a quick request. Can you enter presentation mode?
Can you see? Okay. So I just use standard Debian container, and then I just install all required packages. Nothing interesting till here. Then I install Nginx server that will provide us. Actually, not really needed, but I just want to collect statistics from it. And supervisor that could be, it's a service especially for Docker to run multiple services in a single daemon. So then I just install all stuff required for tick stack. As you can see, Cassandra is not needed here. I just wanted to show it on demo, but I haven't enough time for that. And then I just upload all configurations for these services. Nothing really interesting here. Configs are really simple. If you see, it's just Nginx configuration and standard configuration file for Telegraph that collects something from your service. It looks like this. You say that you want to monitor it, and some kind of param that tells about how to connect to the service. For example, here you need only URL to status endpoint for Nginx that is built in. And in most cases, they are similar. I won't spend time for all of them. What you know more about it? Also, I use Docker Compose. That is just describe how I want to start this container, to not write long lines with Docker. So I just start this Docker file that I showed before, and just forward these ports that are influx related. Nothing special, actually. And now let's try to start it. Can you see it? So we start our server. Okay, it tells us that it started 5 services. One of them is not needed for us. And now we can try to open the web. So if I open on my local host, I will get into these dashboards. So we can see here host list that was connected. If we have multiple instances of Telegraph on multiple machines, we will see this a lot of hosts. So you can monitor a cluster here. So each Telegraph is some kind of client that reports metrics to monitoring server. So actually I have a single machine here, so that's why we see only one. And some basic graphs you can see from the from the scratch. So you can see already connected Nginx graphs. You can see basic system metrics, and here is very convenient data explorer. So we can, as you see, here is a request that I want to use to draw this graph. So what it means? It means that we select from request table. It's called measurement in DEVCLUB.EE. Oh, you have a laser, okay.
The green button.
Oh, okay.
Other side.
Oh. So here's a measurement name, a database name. This is a retention policy, but in most cases, if you doesn't define them, you will have out again. And here we specify what fields we want to select. In where criteria, we can use time in any query, or if you specify text, it's some kind of indexes that you use to filter your group data. You can specify also there. So, but if you don't want to write secure code, you just can use this helper. So you see that, okay, here is a request. You have, oh no, this is not.
Maybe you zoom in.
Let's try. Ah. Okay. So, for example, we can. Oh, it's not very interesting. Nginx. Nginx. Okay, we want to show the Nginx requests. So we select engines, and here we see all the fields that we can show. For example, we want to see currently active and how many requests. So it starts to draw graph instantly. For example, if we want to filter something, actually there is nothing to filter, but we can check here and we will see only this host. For example, if you have multiple hosts. In next demo, I'll show a bit more. But it's easily to draw any graph from the metrics that you have. For example, let's try to. Come on. So, very convenient. You can select any range that you need. Double click, you return to range you want. But this is not really interesting because any monitoring can do that. Let's do something that is more interesting. So I wrote a bit application that will send us its own metrics, and they will be more interesting for observation. Actually, all this code you will be able to see in GitHub in the end of on last slide. There will be a link.
Is it including this tick stack configuration?
Yes, you can see that here is a Docker directory where you can assemble your own and an application. I wrote it on Scala because I'm a fan of Scala, but if you write in Java, for example, there is no problem to use this approach in Java because the library I used is Java library. I just adopted it in Scala code, so no any difference. What I do here, I just create a simple HTTP server that can handle some request. So this means that all requests that came to demo path will be directed here. Here is the get method. And if something came to root path, this kind of operation will send a metric to our monitoring server. Here is the name of metric and a map that tells what kind of tags I want to use. Here I define a tag type, what kind of request I'm doing here, and the value for the tag. I'm showing the form. So for those who doesn't know Scala, this is a general hash map here with one value. And the same way for other paths, you can find that I send metrics for different situations. Actually, this is an application that we will use to give you some licenses for IntelliJ. So I'll tell a bit what it does. So it shows a form that you fill your email and a rate today, place, how you liked it, and send it to the server. After we will see the results, and our random generator will select somebody who will win. So this winner will show us who will be winner. This is standard resources, nothing interesting, just but as you see, it constantly I sent some kind of statistics.
Question, how do you send the sticks? You serialize them to JSON?
Good question. I'll show you what this method does. Actually, I wrote a simple class that just wraps influx library. As you see, here is influx library. In Maven repository, it's called influx Java, so you can find it in Google. On the start, it connects to influx, checks if database exists. If not, it creates one. Then I'm telling that I want to batch all the metrics by 1,000 measurements or send every 10 seconds. So you will be sure that you won't overload, overuse your network. You won't overload some resource, and you're sure that every 10 seconds, anyway, you will have these metrics, if they are. And I've created helper functions. Create tick, it means that just mark that some event happened, and create point, it's give not just tick, but also provide some value, for example, response time and so on. So you, in this case, you just specify map with key and value. It will be used for indexing. And in this case, you have extra fields where you just specify field name and its value. So, and then I use standard influx library where I create point in its format and write it to InfluxDB. All simple. Yeah.
How guarantee that it will do the shutdown? How much for shutdown or you must
Why you need it, for example?
in some case, I will try to read some.
Yeah. Yeah. Actually, monitoring data is not the thing you can't lose. For example, if you require to have it, if you're afraid that you will miss something, just send every second. But it wasn't designed to be durable. For example, if you reboot your server, to keep all unsaved stuff. So in this case, you can invent your own will or use some kind of queues like GMS and so on. But actually, I never faced this situation when I can't lose metrics. If you stop virtual machine, it will flash all unsaved changes.
So it keeps, it aggregates the events in memory and sends everything.
Yeah, it's just for traffic optimization. You can switch it off and you send it instantly. Yeah. I tried it, this approach with very big load, and I haven't noticed any problems on application side or on influx side. It could handle it without any problems. So it won't produce any excessive load. So, and let's start this application. Okay, quick enough. It's already working. And here's our demo. Do you remember these crocs?
Huh?
where I kept these Crocs stuff.
Center rock. Downloads. The first tab, I think it's running already, no?
Yeah, it's running, but I can see where.
The address you mean?
Yeah. Oh, maybe it was separate console. No.
Looks like it's not running.
Okay.
You need a hand?
Maybe. Куда закрылось такое?
Здесь, можно? Тильда здесь, да? Нет? А где у тебя тильда? Тут.
Там-то впереди что-то написано.
Is it tilde?
Okay.
I can't really see.
Давай.
Screen mirror.
Let's mirror the screen, yeah, it will be easier.
No. I think we're good. К 80 просто портим и все. Или HTTP. HTTP 80.
4 восьмерки. Okay, let's try it. So
The demo is running on a different port.
yeah.
9000.
Oh, yeah. What I'm doing, I'm trying to show my local host available on the net. So it's called demo effect. It always happens. Really? Okay, so everyone can open it on your device and try to I will try to show it in a big form. This URL.
Generate QR code. Scan it. Oh, it's just too many connections. Yep.
Whoa.
Raise your hands who managed to connect to it. Okay.
Oh, it's in grok limitation.
Yeah.
Actually, I see that somebody is able to connect.
Per minute.
$20 connections per minute. Nice service.
If you have to upgrade to paid plan.
Yeah.
Okay, then first 20 are participating in the draw.
But they can't move ahead.
Just 99.99.
So okay, you keep trying, but I'm show you what happens here. All those who will be lucky, they will have more chances. So what you can do here, you can write your email and rate this place. I like it very much, so I give 10. And we already have some votes. This is rate distributions. 3, somebody put 3. Okay. But we can see that for most guys it was big pleasure to be here. So but why I'm showing this? Meanwhile, I'm collecting this statistics, what is going on in my service, and how this metrics traps that I've placed in the code are telling me about service usage. Now if I return to my page with chronograph, I can select demo. This is a database that I created for monitoring of my application. And here we can see requests. So if we click value, we can see that there were, in most cases, one connection, but it's already applied a function, mean that wasn't what I wanted, but why to my? It's not really what I want to see.
Does it say there's always been one connection?
No, it can't be. Something.
Maybe this request is something different, like request count.
No. It should work.
So maybe you explain us what is going on, what is wrong.
Actually, it looks like statistics isn't can't reach database, but I can't see any messages about that.
When I have an idea, that's
Yeah. It's demo. It always happens. But it was.
Maybe from here, maybe we can see some, say, business metrics, or like how many people reach the site, or how many.
This what was I was going to show you, but
Okay.
but I see that only one connection at a time. It just can't be. I'll check one thing. It worked, I promise. Okay, but some result that we can see that for each request type there should be bigger numbers. You can see that those traps that we set in the application, they are all here. For how many form views, how many results were shown, how many answers, and resource requests. So I expected a nicer graphs here. This is all about application data explorer, but you can also create some dashboards. They work similar to Data Explorer, but you can save them and use for everyday use. For example, you create some query. For example,
Nginx is supposed to show some graphs.
yeah, we will place it. You say it, for example. For example, maximum requests, and for example, let's add Nginx graph. Nginx. So we can see that there were a bit more than one connections. So this same picture we should see in the requests graph. And we can see that 5 connections in parallel was the maximum count. So here we can sort them, we can move them, and so on, like general dashboard. It's if somebody used Grafana, it should look similar. And we can save this dashboard, give it name. And it will be saved in dashboard list for future use. But now we want to see who the winner. How many winners we will have?
We have 2.
2. Okay. The first one is this one.
Davides. All right. Congratulations.
I'll write down here. And second one,
Sergey from Plumber. All right. Congratulations to you too. So, in terms of how exactly do you get your licenses, I will pass over the contacts, the form required to fill, like first, last name, and the email, right?
just email.
Just email. Okay. You guys need to hand over your first and last name, so that then we can forward all the data to the JetBrains guy at DEVCLUB, Anton Arkhipov, and then you will be gotten in touch. This is how it will happen.
So, let's return to the slides. And I'll tell a bit more about additional tricks, because you can collect additional statistics using some general tools. For example, you can parse logs using just tail and grep and send some metrics using it, because Telegraph can help you with that. Actually, this was the tool I used in the 90s, but I wrote my own solutions. Exec, you can run some script, shell script or Perl or Python that will return some values, and you can send it to Influx and graph them. And there is also plugin that could read JSON data and send it to Influx in some way, like measurements. And of course, you can use database queries. For example, if you have some information about statistics in your SQL database, you can just select it and send. But don't play much with it, because you can hit performance and make things worse. I'll just show you a quick list of plugins that Telegraph supports. Just to give the understanding of how many of them. These all services that it could connect to and take measurements from. It can even take measurements from Amazon, console, different databases, DNS, Docker, and so on and so on. A lot of them. So you can see that you can monitor almost everything. And Jinx that I showed you is just one of them. But it's not just important to collect metrics, but to react on them. So in most cases, you want to have some kind of notifications if something bad happens. For example, if you see that your disk is going to be full, you spend 95% of its volume. So you need to be notified that you should go and clean something or resize it and give it more space and so on. So the capacitor that is used in this stack supports emails, SMSs, Slack, Telegram, and many other canals as you want. So it has its own robots, but I just don't have enough time to show this kind of presentation. So
question. So have you used Telegram? Does the Telegram still works? You know that you send a Telegram and the post office guy comes off.
That's an app.
It's application.
It's not quiz time, so
So I try Slack. It works well. And of course, email and SMSs. That's all. If you have some questions, here is a repository that I showed in demo. You can try it at home. So if you have questions, I'll be glad to answer.
I think we owe a round of applause for Jevgeni. Now we have time for a couple questions. Any questions from the audience? Yes?
So you showed us the scenario for alarms, or actually you just mentioned that it would be a good idea to have them, but in real life, rarely it happens that you get a single bad event, but often you get like cascading situations, you get cascading alarms, and do you have any, I don't know, best practices on how to handle these cascading failures so that the notifications that you end up receiving, that you won't drown in the volume, that how you manage it?
First of all, go and solve this problem. If you constantly receive the same alarm, you just go and solve it, or just turn off this alarm. Because if you don't solve this problem, why you want this alarm?
Oh, the question was a little bit different. So, like you mentioned, like everything was okay, and then at night just goes SMS non-stop because something is wrong.
Oh, if you see repeated alarms, actually you can play with state. For example, you send alarm when state changes from good to bad, and for example, from bad to good. Like it used in Jenkins. If you build files, you receive notification, and you can customize it to not send notification when state repeats, and only when state changes, you will have this notification.
So this is something that you usually have implemented in business logic, right?
Yes.
Similar question, but not on repeating events, but like if you have a lot of nodes, a lot of instances, a lot of data centers, and something global happened, for example, like all instances, all machines got affected. So every monitor, every instance will notify how that system solved this problem.
I don't think that it solves this problem, because you have a lot of triggers that fired at once. So it's okay in this case. But I don't think, if you have a global problem, then in most cases your monitoring will go down also.
Like imagine you have 100 nodes running, right? And then you get like a notification that one is down. Then like you want to know still if second, third, and fourth go down. But after that, you probably don't care anymore because you see the pattern, and then you basically ignore the notification and switch to.
Yeah, it could be like your dependency service is down, so all your instances come. So it's kind of
Like a load balancer is down, and then okay.
Yeah. You use some other service, like let's say like Google in this example, right? And your connection to Google is broken, or Google itself is broken. So all your instances will have exactly the same problem, right?
Yeah. But then normally you either like you distinguish like is it like one node? It's like all nodes.
It's host specific or cluster specific problem.
Yeah.
But
yes, correct. I have a question too.
okay.
it's more of a general, like good practices of performance monitoring. Would you store and analyze access log together with other monitoring data or separately?
Actually, Nginx plugin shows you numbers that tells us how many users came. But access logs tells you a bit more about who came.
And where?
And where, yes. But if you need this information, so I actually tried to show it inside the application to point where user comes. But another way, you can just write some log parser that will send the statistics to monitoring server, and you will have the data that grouped by some request path, for example, or some kind of geographic location if you have GeoIP model enabled, and so on, so on. Actually, you can segment your data from access log in many ways.
But from your own practice, do you also use the tick stack for storing and processing, monitoring this access log data?
As I said, I just get it from the application, not from access logs. But I have almost the same data, but in this format that I easier to put it into the influx. I just don't have to parse it.
I have a question. So elk is not good anymore?
What?
Elk.
Elasticsearch, no, I use it, but it's a bit different thing.
Oh, you can do.
It's more, if you want to compare to these graphs, Elasticsearch for me is like some storage for logs where you can find log records that you need, but it's not about overview and so on. It's for digging deeper.
What do you think about Prometheus for metrics collection?
I've heard about, but never tried. I think it's paid solution, no?
No?
We had a demo the other time at DEVCLUB. The last one at Playtech, Jonathan did on Prometheus and Istio and stuff.
Yeah.
Yeah, so the video is available on DevClub channel, so you can go look up.
I used to. It's pretty
So that's it. Thank you, Evgeny.